See, stereochemical study. Okay, see how this technique is used to write the mechanism of the reaction. Okay, you have studied in 12th standard, that is what is meant by SN1 and SN2 reaction. SN1 reaction and SN2 reaction. If we see the in SN1 reaction and SN2 reaction, see the stereochemistry of the reactant and the stereochemistry of the product. Okay, what happens in SN1 reaction? In SN1 reaction, that is we get the mixture of product, that is 50% retention and 50% inversion of product of the reactant. Okay, and in SN2 reaction we get the 100% inversion. 100% inversion. Okay, see simple reaction. See how this stereochemical study is used to write the mechanism of reaction. See simple reaction. See, tell me what is the name of this? Okay, alkyl halide. See, CH3Br. Okay, that is only reaction with alkali. Alkali, that is we get, see this compound, we get this H, C, C6CH5, CH3 and OH. Simple substitution reaction, this Br is replaced by OH. Okay, and again we get OH, C, H, C6H5 and CH. Okay, stereochemistry change. Okay, this 50% retention, 50% inversion. Okay, tell me the stereochemistry of this reactant. What is the configuration? Whether it is the S or whether it is R configuration. What is the name of this? Means it is known as the 2-phenyl ethyl bromide. Okay, 2-phenyl ethyl bromide. Okay, what is the configuration? Whether it is R or it is S. Yes or R? See that is first priority. Which is first priority? 1. Second priority? Third. Okay, 1, 2, 3. Anti-clockwise direction. Therefore, this has yes. Means what is the name of this halide? Yes, 2-phenyl ethyl bromide. What is the configuration of this? First priority. First, second, third. That is yes. Anti-clockwise direction. First, second, third. Clockwise direction. R. Okay, means we get the mixture of S alcohol and mixture of the R alcohol. Okay, means see and see the stereochemistry of the reactant is S. And remember, if we study the stereochemistry of this product, okay, we get 50% S alcohol and we get 50% R alcohol. What is your conclusion? No doubt, this is the simple nucleophilic substitution reaction. What is the mechanism of this reaction? Whether it is SN, whether this reaction follows SN1 pathway or whether this reaction follows SN2 pathway. SN1 pathway. Why? 50%. We get 50% retention of configuration and 50% inversion of configuration. Therefore, this reaction follows SN1 pathway. Means the mechanism of this reaction is like SN1 reaction. And we know the mechanism of SN1 reaction. How this SN1 reaction takes place? Or what is the mechanism of SN1 reaction? SN1 mechanism? What is the mechanism of SN1 reaction? That is mechanism of this reaction. See? That is first stage, that is formation of carbocation, correct? Speak loudly. That is we get this. Okay, see? H. Okay? C6H5 and CH. Okay, that is we get this carbocation. Okay, we get this carbocation, planar carbocation. Okay, and the next step is the attack of nucleophile. Okay, if this nucleophile attack out from the front side, then we get this alcohol and if this nucleophile attack from the back side attack, that is we get this alcohol. Means the mechanism of this reaction is this. That is, this reaction takes place through the formation of planar carbocation. Means like SN1 reaction. Okay, means by studying or by knowing the stereochemistry of the product, one can write the probable mechanism of the any reaction. 2-phenyl ethyl bromide. Okay, what is the combination? That is the S. Okay, and in the product we get the S alcohol and R alcohol. Okay, that is the mixture of alcohol. Okay, means there is 50% retention and 50% inversion of concentration. Okay, means what is the mechanism of this reaction? That is this reaction involves or this reaction follows SN1 pathway. This reaction follows SN1 pathway. Okay, next example. See, next example means see, this reaction follows SN1 pathway. Okay, SN1 pathway. Okay, means this mechanism of this reaction is like the SN1 reaction. Okay, second example. See, second example, H C CH2 CH3 CH3 and Br. What is the name of this compound? What is the name of this compound? 1, 2, 3, 4. 2-bromobutane. Okay, and what is the configuration? Whether it is a S or whether it is R?
Yes.
First priority 1, 2, 3. Anticlockwise direction. Okay, that is yes configuration. Okay, only reaction with alkali. That is we get. See. That is we get. See. CH2, CH3 and CH. What is the configuration of this alcohol? First priority, second, third. 1, 2, 3. That is clockwise direction. Therefore, this is the R alcohol. Okay. Means there is 100% inversion. There is 100% inversion. Therefore, what is your conclusion? This reaction follows SN2 pathway. Means the mechanism of this reaction is like SN2 reaction. Okay, because there is 100% inversion of concentration in the product. See, total stereochemistry change. Okay, reactant. If we see the stereochemistry of the reactant and the stereochemistry of the product, it is clear that this reaction follows SN2 pathway. And this first reaction, there is 50% retention and 50% inversion of concentration. It clearly indicates this reaction follows SN1 pathway. Means what is the mechanism of this reaction? Write the mechanism. We know SN2. That is the partial breaking of the bond, CBr bond. At the same time, there is the partial making of the bonds between this carbon and OH. Okay, what is the mechanism of this reaction? What is the mechanism? See the mechanism of this reaction. That is okay. See, that is okay. See, okay, this nucleophile. Okay, attack from the back side. Okay, that is we get. See. H, that is CH2 CH3, okay, and CH3, okay, that is see the partial breaking of yes CBr bond. At the same time, this nucleophile OH attack on this carbon, okay, that is the partial making of this one. Okay, this is the transition state. Okay, this is the partial breaking of the CBr bond. This is the partial making of the. Okay, the next step is the next step, that is we get. Next step, that is we get OH C H, CH2, CH3 and CH3. Okay, there is a complete formation of bond between this carbon and oxygen. Okay, this is the mechanism of this reaction. Okay, means in short, remember, by knowing the stereochemistry of the product and by knowing the stereochemistry of the reactant, one can write the mechanism of any reaction. Okay, means using the stereochemical study of the reactant and the product, one can explain the mechanism of any